A warm welcome to everyone who's watching this presentation. My name is Martin du Plessis and I'm a PhD student at Stellenbosch University's Department of Industrial Engineering, and I'm supervised by Prof. Hubert van Eden and Prof. Lila Goedal-Scherwe. And this presentation will be discussing 3 years of research which I've done as part of my PhD project, and in basically the project developed a carbon mapping framework for the international distribution of fresh fruit, specifically from South Africa. So here we go. Just a bit of background on the South African fruit export industry. South Africa is the biggest exporter of fresh fruit by volume in the Southern Hemisphere. South Africa is also the second largest citrus exporter in the world. And during the 2020-2021 season, South Africa exported nearly 3.6 million tons of fresh fruit, which translates to nearly 180,000 40-foot reefer containers. In terms of the markets to which we exported this fruit, the European Union represents about 35% of the fruit exports, followed by Asia, the Middle East, United Kingdom, and the remaining regions represent a smaller portion. In terms of the type of fruit that we export, citrus represents the vast majority of fruit exports, followed by your pome fruit, that's your apples and your pears, and then table grapes, and the remaining three categories, which is stone fruit, your peaches, plums, subtropical fruit like your avocados, and your exotic fruit like your blueberries represents a mere 5%. So why would the South African fruit export industry want to assess its greenhouse gas emissions? And Prof. Alan McKinnon summarized the problem at hand quite brilliantly in his 2018 book titled Decarbonizing Logistics, when he stated, climate change has evolved from being just another environmental problem to potentially the greatest threat facing our civilization. Amongst our consumers, there's a heightened awareness of greenhouse gas emissions and the potential impact of these gases. And consumers are subsequently demanding visibility of value chain emissions and supply chain emissions. And for South Africa, it's important to mitigate the trade risks for the fruit export industry, because we might be exposed to a new carbon barrier in future, similarly like what the European Union is planning to implement by 2026 for carbon intensive products such as steel and cement and aluminium. So it will become increasingly important in the future for the South African fruit export industry to assess its emissions. And this also gives the South African fruit export sector a market advantage above its competitors like Chile, Peru, Argentina. So it will become increasingly important across the board for various reasons for us to assess our emissions. The problem that we're faced with is visually summarized on this slide. Starting at the left-hand side at a packaging facility in South Africa, fruit is packaged and distributed throughout various supply chains until it arrives at the port of discharge. Each of these activities in your distribution chain emits a certain amount of greenhouse gas emissions. How much is the question? So we need to determine the emissions of each of these activities, followed by the total emissions of the entire distribution chain. This is then needed to calculate and reallocate the emissions of all the fruit that was distributed throughout your distribution chain. And this problem was confirmed by a journal article that was published in Global Food Security. And this article just summarized two problems basically. There is no carbon mapping framework that can service the industry standard. So there's no recipe to calculate emissions with. And secondly, there's insufficient emission intensity factors. So how do we know that the factors that we use to calculate emissions are a true representation of the actual emissions emitted? Now that we've identified what the problem is, we can discuss the proposed framework. And the framework is basically a 20-page document that provides comprehensive yet understandable guidance specific to the South African fruit export industry and related stakeholders. And it's very important that each of these frameworks in future be developed specifically for an industry, because the logistical circumstances is unique from one industry to another. So basically we provide in this framework, we provide stakeholders firstly with a recipe to calculate the emissions, and secondly emission intensity factors for each of the emission generating activities throughout your distribution process. Before we dive into the detail of what each of the steps in the framework consists, let's have a brief overview of the 6 steps in the framework. The first step is the most important in the entire emission estimation process. And this first step identifies all the emission generating activities between the door of a packaging facility in South Africa and the port of import. So this first step identifies all the emission generating activities between these 2 points. Then for each of the identified emission generating activities, steps 2 to 5 are performed. The second step entails the collection of data of the specific activity. The third step entails the selection of emission intensity factor from the values that we recommend in the framework. The fourth step combines step 2 and step 3 to calculate the total emissions of that specific activity. And the fifth step divides the emissions between the fruit involved in that activity to determine the carbon footprint. And the sixth and final step of the framework is just a summation of the total greenhouse gas emissions of each individual step to determine the total greenhouse gas emissions of the specific distribution scenario. Now that we've had an overview of what the 6 steps in the framework are, we can dive a bit deeper into what each step entails. So the first step in the framework is where we identify all possible methods by which the fruit can be exported. And we developed a journal article that maps all possible logistical scenarios by which fresh fruit can be exported from South Africa. And the journal article consists of 5 diagrams, and this captures all possible logistical scenarios. These diagrams are quite comprehensive and detailed since they capture transportation modes, transportation configurations, storage locations, etc. So the diagrams, the 5 developed diagrams, can basically be split into 2 different groups. The first group entails the movement of fruit directly from a packaging facility to the port of export without storing the fruit, so the fruit doesn't move through a logistical facility, while the second group of diagrams represents the movement of fruit via a logistical facility, such as a cold store, container facility, or a rail storage facility. So 2 different sets of groups. Just a brief overview of the diagrams. Here you can see the movement of fruit via road transport directly from a packaging facility to the port of export, and you get 2 different types of functional units. You get either reefer containers, the second row, or you can export the fruit via pallets. The same applies to exporting the fruit via air freight. Here the only thing is you can only export the fruit via pallets. Then the complexity increases exponentially when we start to move the fruit through logistical facilities. On the left-hand side, there's an N logistical facility repetition. So your fruit can have N movements via logistical facilities before it eventually arrives at the port of export. Then you can also move the fruit through a logistical facility before it is exported via air freight. And finally, you can export the fruit via N logistical facilities via rail. Now that we've identified all the activities that should be included in the assessment process, we can go and collect data of each of the activities identified in step 1. The framework is multifaceted in this aspect of data collection since it consists of 2 different levels. The first level is for actual shipment data, so the user can input or provide the framework with the actual shipment weight, the gross weight, the net weight, the actual distance traveled by a road transport vehicle, the actual storage duration, this type of primary data that is unique to each shipment. In the absence of this primary data, the real shipment data, the framework suggests alternative values. So in the absence of that, the framework recommends that you use these values. And that applies to weight, to distances, what losses should be accounted for in the distribution process, and what data should be collected for each of these emission generating activities. After the user has collected all of the data required in step 2, the user must now select an emission intensity factor for each emission generating activity. So here the framework is unique since it suggests a comprehensive set of emission intensity factors for all possible emission generating activities. And this is really where the framework makes a unique contribution. Instead of only providing a recipe by current standards, we also suggest what the emission intensity is for various different logistical activities or distribution activities. The framework suggests a comprehensive set of emission intensity factors for all 4 modes of transportation, particularly for road transportation. On the left-hand side, various configurations of road transportation vehicles used to export fresh fruit in South Africa are shown. The estimated emission intensity for various percentage of empty runnings and load factors are shown in the table. And these values are representative of the fruit export industry. So the inputs used to develop this first known set of emission intensity factors was two journal articles that we developed as well. The one on the right hand side is a published journal article in the South African Journal of Industrial Engineering, and this calculated a set of emission intensity factors for South African LSP that transport bulk liquids in South Africa. And the one on the left hand side is a journal article that is currently in review in Transportation Research Part D, and this is specifically for a LSP that is involved in the pre-carriage of one of the biggest avocado exporters from South Africa. So a comprehensive set of data was used to develop these emission intensity factors for road transportation vehicles. The framework also suggests comprehensive emission intensity factors for the remaining three modes of transportation. For rail transportation, we developed an emission intensity factor for container transportation in South Africa. This value is, however, based on simulated data due to data limitations. For deep sea ocean transportation, on the right-hand side, we obtained detailed data from the Smart Freight Center for various trade lanes by which fresh fruit is exported from South Africa. And on the bottom is a emission intensity factor for conventional reefer vessels. And this is the first known value globally that is focused specifically on reefer vessels. And this was calculated from primary data supplied by LSP that owns and operates a big fleet of conventional reefer vessels. And your air transportation emission intensity factors were supplied from the Smart Freight Center. The GLEC framework, of course. The framework doesn't only suggest emission intensity factors for the four modes of transportation. It also suggests a comprehensive set of emission intensity factors for various types of logistical facilities that handle and store fresh fruit. The framework enables and promotes a fundamental shift in accounting methodology of refrigerated products. Previously, we based our emissions only on the weight or volume of goods that move through a facility. However, this neglected the storage duration, which is fundamentally wrong for refrigerated products. So the framework developed a set of emission intensity factors for pallets and for containers, separating the handling of the goods versus the storage of goods. And this separation enables us to calculate storage emissions versus handling emissions at a logistical facility. And we developed a journal article specifically for cold stores, and this is also the first known emission intensity factor for cold stores that handle and store fresh fruit. For each of the emission generating activities, we can now go and calculate the emissions. Using the collected data from step 2 and the selected emission intensity factor from step 3, a simple multiplication sum is performed in the fourth step of the framework. And this calculates the emissions of that specific activity. The fifth step of the framework, we divide this amount of emissions, this kilogram of carbon dioxide equivalent, to the fruit involved in that specific activity. And this gives us the carbon footprint of that specific emission generating activity. So XYZ kilograms of emissions are emitted per kilogram of fruit. The sixth and final step of the framework determines the overall carbon footprint as well as the total emissions of the distribution process. And this is simply achieved by summing the emissions of each emission generating activity together. Now that you've had a crash course in the framework, you may ask, how was it developed? And to simply answer this question, 7 different types of inputs were used and triangulated against one another. This being the best literature there is, such as the GLEC framework, the GHG standards, several different types of observations at logistical facilities, ports of exports, fruit packaging facilities in South Africa, the various emission intensity factors involved and developed during the project, the distribution chain diagrams, several semi-structured interviews of subject matter experts such as Prof. Alan McKinnon, Prof. Toby Peters, collaboration with the fruit export industry in South Africa, and finally the iterative application of the framework to several distribution scenarios, which will be discussed in the next slide. The framework has been applied to 7 example scenarios by which fresh fruit is exported from South Africa. These example scenarios form the basis of a future journal article that will be developed next year. But one example I want to bring to your attention is that of avocados exported from South Africa to the port of Rotterdam. Deep sea ocean transport is responsible for a large portion. However, the remaining emission generating activities are responsible for nearly 45% of the total emissions. So these activities cannot be neglected. So where to next, you may ask? The first is we want to develop a journal article for the 7 example distribution scenarios which use the framework. The second thing is we would like to do a journal article to estimate the total distributional emissions of the South African fruit export industry. A third journal article to compare the distribution of fruit via reefer container versus conventional pallets, to compare these 2 export scenarios. And then we are open for future collaborations. So if you have any other ideas, please contact us. Thank you very much for watching this presentation. I hope you enjoyed it and you find it of value as the fruit export industry does. Thank you.